In this video, we're going to be looking at extending from roots of quadratics to roots of cubics. So a cubic equation of the form ax cubed plus bx squared plus cx plus d equals 0. There's a whole pile of working out here, but it's very similar to the last one. But basically, we get to the sum of your roots. So alpha plus beta plus gamma. If there are three roots, then your sum of your roots is equal to minus b over a. Now this is a bit weird, this is where it's a wee bit different. This is the sum of the pair of the products of the pairs. So alpha beta would be one pair, one product, beta gamma would be another product, and the other product you're left with is gamma alpha, and that is equal to c over a. And the last one is alpha beta gamma, so that's just the products, is equal to minus d over a. Now this is a wee bit awkward to remember, but if you just remember the first one, the sum of the roots is the same as it was for the quadratics, I should say. It was minus b over a, and then this one is c over a. So the sign, the bottom letter always stays the same. It's always the a, and the top letter just goes from a alphabetically on to c on to d, and the signs alternate. So it's minus, then positive, then minus. So you may not remember what these are, but if you remember the first one, you can work to them. So if you remember, the first one is minus b over a, so that was just for the sum of them, alpha, beta, gamma. And the next one is the sum of the pairs, the sum of the products of the pairs. Then it's still a in the bottom line. Now you go from b up to c, and the signs alternate. So the first one was minus, so the next one is positive. Likewise, then if you've got here, then you can get to the next one by moving from c onto d, and the positive changes to negative, so it's minus d over a. Okay, their way of saying it here is as with the rules for quadratic equations, the sum of all roots is minus b over a. The sum of the products of all possible pairs of the roots is c over a. You can see here I've just said that the sum of the pairs, and I've called the first one the sum of the roots, the sum of the pairs, and then the products. So that's it. So whatever way you want to say it. Okay, we're going to look at the example here of how we can use this, and see it's not that difficult at all. Okay, so it says alpha, beta, and gamma are the roots of the cubic equation 2x cubed plus 3x squared minus 4x plus 2 equals 0. Without solving the equation, find the values of alpha, beta, plus gamma. So first of all, first thing to do here would be to write down what your coefficients are. So a is equal to 2, your b is equal to 3, your c is equal to minus 4, and your d is equal to 2. And then you're good to go. So alpha plus beta plus gamma, from what we have in our notes, is equal to minus b over a. So in this case, minus b over a is going to be minus 3 over 2. For part B, this is our sum of the pairs. So all possible arrangements we have for the pairs. And this is going to be equal to c over a. So just remember here it was minus b, so it becomes positive c, and it's always over the a. And then we just put that in and see what we get. So your c was equal to minus 4, your a was 2, so that's just going to work out nicely as 2. Next one, part C, this is your triples, so alpha, beta, gamma, and alpha, beta, gamma is equal to, and it's going to be minus d over a. So again, the last one was c over a, next one's going to be minus d over a. So just put that in. Your d is equal to 2, so that's minus 2. Your a is 2, and minus 2 over 2 is 1. Okay, the last one again probably just requires a little bit of manipulation. We've got 1 over alpha plus 1 over beta plus 1 over gamma. So if you did that out, you would have to do, it's an algebraic fraction, you have to do a common denominator, alpha, beta, gamma. Top line is going to be this one here needs to be multiplied by beta, gamma. The middle one needs to be multiplied by alpha, gamma, and the last one needs to be multiplied by beta, alpha. Now if you look at that top line, what you have is the sum of the products, so what you've already worked out in part B, which was minus 2, and the denominator or the bottom line is just going to be minus 1. So minus 2 divided by minus 1 is just 2. Okay, now apologies about this one, but our complex numbers have appeared in here, and it's good to have it in your notes at this stage. So it is not overly complicated, this at all, what we're going to be doing at the minute. But what would basic crash course in complex numbers, we'll do this over to the side. So for complex numbers, okay, we know, or what we've been told up until this point is that you cannot have the square root of a negative number. Now, somebody persisted along the lines many years ago, persisted with the idea that they could have a square root of a negative number, and they're called complex numbers or imaginary numbers. So what we've told you has not changed, because we've always said that there are no real solutions. So for example, in the quadratic equation, if you have x is equal to minus b plus or minus b squared minus 4ac, all divided by 2a, we always said there were no solutions if this part of it, which remember is the discriminant, b squared minus 4ac, if b squared minus 4ac is negative, then there would be no real solutions or no real roots, we would have said. So that hasn't changed. There's still no real roots, but they're called complex roots or what's called imaginary roots as well. So when they say that word imaginary, a complex number consists of 2 bits. If you look up here, this is the real bit and this is the imaginary bit. So we have to figure out what I is. So I is actually equal to the square root of minus 1. That's what I is. So if you did I squared, you would get minus square root of minus 1 squared, which just gives you minus 1. Okay, right, adding or subtracting complex numbers. If I was adding these two, up here, I would add the 2 real parts, and I would add the 2 imaginary parts. So just add them like their normal algebraic expressions. So minus 2i plus 2i, they would just cancel out and give you 0, and that would be it. Okay, we're going to look at this question, and we're going to go through it, and I will go through it in great detail, anything that I think will be any difficulty for us. So I'll just get rid of all of that now before we get started. Okay, we'll work through this question now. It says the roots of the cubic equation ax cubed plus bx squared plus cx plus d equals 0 are alpha, which is equal to 1 minus 2i, beta, which is 1 plus 2i, and gamma, which is equal to 2. Find the values of a, b, c, and d. First thing we're going to do is write down alpha plus beta plus gamma and write down what they are. So it's 1 minus 2i plus 1 plus 2i plus 2. So if you add all the real bits, you've got 1, you've got 1, you've got 2. Adding those up, you get 4. Imaginary bits, you've got minus 2i and you've a plus 2i. So minus 2i plus 2i is 0. So you've your alpha plus beta plus gamma is just equal to 4. So that tells you minus b over a is equal to 4. That's the first thing that we've got. Okay, next thing we've got is we're going to look at the sum of the pairs, or the products of the pairs, as we could say. So my pairs are alpha, beta. Just work through these in whatever way you come to it. I'm going to do all the alphas first. Alpha, beta, then alpha, gamma. Then you've got beta, gamma. Is that it? I think that's it. Yep. So alpha, beta plus alpha, gamma plus beta, gamma. That's it. And they are going to be equal to, so we're just going to work through. So my alpha times my beta is going to be 1 minus 2i, 1 plus 2i, and then I've got I'll go underneath there. I know it's a bit weird to do this, and then got my alpha times my gamma will be then 2 times 1 minus 2i, and then my beta times my gamma is 2 times 1 plus 2i. Right, show you're working out well here, and it will stand you good stead for later on, and you'll see why. So the first one is I'm looking at this, sorry, 1 minus 2i upon 1 plus 2i. Now what you should notice, this is a difference of 2 squares. I'm going to show all my steps for this. 1 minus 2i upon 1 plus 2i. So that will become, I'll put this in a bracket, that's going to become 1 squared minus 2i squared. And then my next thing is a lot easier, so I'm looking at this bit. This is 2 upon this thing, which is just going to, I'll just multiply it out. That's going to be 2 minus 4i. I'll leave that in a bracket. And then the last one is going to be plus 2 plus 4i. Okay, we'll look at this one. This is where it gets a wee bit tricky. 1 squared is dead easy. That's just going to be 1. And then the 2 squared, sorry, it's minus then 2 squared is just going to be 4. So that's just going to be minus 4. And I squared, remember, I squared gives you minus 1. So I squared will just be, that's going to be 4 upon minus 1. And then over here, we'll tidy this all up. You had the 2 plus the other 2 here, which is just going to be 4 minus 4i plus another plus 4i is going to give you 0. So that's all you're going to have. And tidy this up in here. Inside this bracket, you're going to have 1 plus 4 plus another 4. And that's just going to be 5 plus 4. 5 plus 4, which is going to be equal to 9. Okay, got a wee bit messy there, but that's fine. So you've got, that means what we've got, sorry, I'll box that off. Therefore, what you have found is your C over A is equal to 9. Okay, the last thing for us to do is to look at the products of all of them. So we're going to look at alpha, beta, gamma. And alpha, beta, so we'll write it out the long way. That's 1 minus 2i upon 1 plus 2i upon my gamma, which is 2. And here, this is why it's important we set this thing out. 1 minus 2i upon 1 plus 2i, sorry, worked out to be 1 plus 4, so it worked out to be 5. So that just works out, those first two brackets just work out to be 5 times 2, so it works out to be 10. Okay, my method for doing these is I'm going to just say let, oops, sorry, I forgot to say, that means, that implies then that my minus d over a is equal to 10. Now my method for doing these, I say let a equal 1. So if you let a equal 1, then we go all the way back over to here, then that means that minus b is just equal to 4. So that means your b is equal to minus 4. And then also, if your a is equal to 1, then that means that your c over a is equal to 9. So c is equal to 9. And also, if you let your a equal to 1, you get minus d is equal to 10, which means d is equal to minus 10. Read the question. It says find the integer values for a, b, c, and d. And we've got them. We didn't actually need to change these ones. We've now got these in integer value form. Happy days. Okay, folks, you're now ready to do exercise 4b, questions 1 and 4.